Hi, my name is Tuturi. I'm a data scientist. Today we are going to discuss on the types of machine learning algorithms, decision trees, and random forest. First, the decision trees. Decision trees is the name implies it's a tree of decisions. In the sense, it has a condition, and then depending on the condition, it it splits into nodes and leaves. For example, uh, the root if the marks greater than 40 pass, yes pass, or no fail. So that's a condition. Depending on the condition, the data is going to be splitted. And in pass, if marks uh, 40 to 50 40 to 50, it is again grouped together, and if yes, it is grade C, and if it is no, it's just third class, D, class D. So that it basically it depends on the condition. The condition, it splits the data into nodes and leaves. So the highest gain of the data in the data set is it starts from we can call it as a root. So from root entire data set if we take, and the highest gain from the data set it calculates, and based on the gain of the highest gain of the feature, the feature in the sense of variable will be termed as a root variable, and then from root it divides again, it splits the data again into nodes and leaves. So that's how it keeps on splits the data into nodes and leaves. So the and depending on the gain, how it splits is depending on the highest gain from that onwards. How it calculates the gain is information gain is based on the formulas we have, based on the information gain, entropy, and Gini, etc. So based on these calculations, it splits the data into nodes and leaves. So that's a decision tree where it will be applicable is if we want to find out whether a customer is going to give a loan or not. So for example, it's a classification. So decision trees can be utilized both for classification and preclusion. So if we are going to the data sets to be classified, we use decision trees. For example, loan status, if it is yes or no, whether we can give a loan to a customer or not. In that case, it's a classification problem. There we can use decision trees. So how it gets the splits the data is by using information gain, entropy, and Gini, etc. So the formulas we can find out in for the how it calculates the information gain. Information gain is basically it's a gap between the uncertainty. That's the information gain. So if you want to split the data, what is the uncertainty of it? Is for the information is the marks is greater than 40. Is that we want to split that? So it calculates the information gain for that particular feature, that particular variable, that particular attribute. So and then it calculates the entropy. Entropy is basically the measure of the uncertainty. So again, it has formulas. So for entropy, we have a formula IP comma n is minus p by p plus n log p by p plus n minus p by p plus n log to n by p plus n. That's our information gain. We have the formula, and entropy we have sigma I equal to 1 to n p1 plus n1 by p plus n into I of p comma n. So that's a entropy formula. And for gain, it's information p comma n minus e of a. So entropy, information gain minus entropy. So that's those formulas are there. So by using this formulas, decision trees will calculate calculate the information, and it splits the data into nodes and leaves starting from the root. So this is all about the decision trees. And second is random forest. Random forest is a collection of decision trees. That's why it called as a forest, because it is having the collection of decision trees. And if it is a regression random forest if it is based on the bagging technology. It uses bootstrap bagging or bootstrapping technique, that is to aggregate the each decision tree given by the result, the predictions given by each decision trees. It aggregates that decisions or the most voted votes, if it is a classification. If it is a regression, random forest regression, it aggregates the each decision tree predictions of each decision trees results, and gives the value, random forest value prediction value. If it is a classification, it gives the most votes of the given by the different each decision tree given in that forest. So it's based on the bagging technology and technique it uses, the random forest. So the other technique is gradient boosting. So boosting is basically it combines the weak learners to form a most powerful learner. So based on it combines all the weak learners. That's boosting technique. It is based on boosting is to combine the weak learners predictions, the weak predicting learners, to combine everything, and it gives a powerful very accurate. Accuracy will be more, because it combines all the weak learners and it learns more, and then it gains all the information, and then combines all the weak learners, and it makes a powerful learner. So there it gives much more better performance, better accuracy, rather a single learner thing. It combines all the weak learners, so it gives more accurate results. So that's a gradient boosting techniques algorithm. So now we discussed the decision trees. We discussed the random forest, which uses the bagging technique, and the gradient boosting is which uses the boosting technique, And each one is each one is had their own advantages. For example, we need to find out the same and the to find out whether the client is whether the customer is going to give credit, loan status, to find out the loan status, whether we can give a loan to the person or not, to predict it. So we can use decision trees. So decision trees will give us classification yes or no, or further that is more a single decision tree. But random forest, if we use, it gives much more better results than decision tree, because it is having aggregates, or it find out it splits the data into each different parts, and each decision tree will give a yes or no loan status, and combines it aggregates it, and it find out because it's a multiple of decision trees that RandomForest will have. It gives the most number of votes given by the it always gives better results than decision trees. And for gradient boosting, if we find out, it combines the weak predictions into a much more better powerful results. So gradient boosting is so what is the difference between random forest and gradient boosting is basically both are assembling techniques. Both are both are random forest and then gradient boost are assembling algorithms, and but gradient boosting will use the boosting technique, and random forest will use a bagging technique. So and random forest will be to reduce the variance. Basically, we will reduce the variance. It reduces the variance, and boosting it minimizes it reduces the biasness, and the more accuracy will be achieved by gradient boosting. So there's a difference between random forest and gradient boosting. Thanks for watching this video. If you like it, please like it and share it. Thank you.